Hello everybody, my name is Hassan Zulfikar and today I am gonna tell you about the Gauss-Seidel method. Gauss-Seidel method is an iterative method which is used to find the approximate values of the unknowns given in a given equation. Gauss-Seidel method is a modified form of the Gauss-Jacobi method. So what we will do in the Gauss-Seidel method, let us suppose we have we have a set of equations like 4u plus 2v plus 4w is equal to 20 and this blah blah blah. And what we have to do, we have to find the values of these unknowns which will solve this equation. We have to find the values of u, v, w and x, and there is no x means the coefficient of x is 0, and in here the coefficient of u is 0 in the fourth equation. So in the Gauss-Seidel method, it is an iterative method. We have to what we have to do, we have to eliminate a cofactor. Like in the first we have in the first equation we will eliminate u1 in and equate it with other all and equate 2v and 4w on the other side and equate it, and the second we eliminate v1, in the third we eliminate w1 and x1. u1 is equal to 1 upon 4 times 20 minus 2 v naught minus 4 w naught. What is v naught and w naught? It is our initial guess. Our initial guess may be 0, it may be minus 10, minus 100 or plus 100. In the second equation, v1 is equal to 1 upon 2 times 36 minus 2 u1. It's u1, it's not u naught, because if we have calculated our u1 in the from the first equation, it is our u1 minus 3w naught. In the third equation we have two knowns u1 and v1. We put in our third equations u1 and v1 and x naught, as we don't have any value of x naught. In the third equations we have all the knowns u1, v1 and w1. So in the third equation we don't use any naught value or any initial values, as we have no x, as we have no u coefficient, so it is 0, and the equation will become 1 upon 9 times 122 minus 2v1 minus 3w1. So we have only three initial guesses: x naught, v naught and w naught. X naught is equal to 0, v naught is equal to 0 and w naught is equal to 0. When we put this in our equation and solve this, we get u1 is equal to 20 minus 0 upon 4, which is 20 upon 4, which comes u1 is equal to 5. When we put this value in our second equation, 36 minus 2 times 5 minus 30 minus 20 is equal to 36 minus 10 upon 2, which gives our value v1 is 13. And again when we put u1 and v1 in third equation, we get our w1 value to be 1 upon 6, and when we put all these values in our fourth equation, we get our x1 value to be 17 over 6. So we can, as we can see that we have our initial values of 0 0 0, and we got to the values of u1, v1, w1 and x1, which is a good which is not a good but a very near approximation. Now in our second case, what this is our first approximation, and in the second case it is our initial guess. So here in the second equation, y2 is equal to 1 upon 4 times 20 minus 2 v1 minus 4 w1. v2 is equal to 1 upon 2 times 36 minus 2 u2 because we have calculated u2 minus 3 w1 minus 2 x1. w2 is equal to 1 upon 6 times 60 minus 4 u2 minus 3 v2 minus 3 x1, and x2 is equal to 1 upon 9 times 122 minus 2 v2 minus 3 w2. We have calculated the values of u1, which is 5, and v1 and w1 and x1. Now we just put these values in the equation to get our values or new values or new approximations of u2, v2 and w2 and x2. This is an iterative method, and it goes on it go it you continue it to approximate or reduce or error. So this is and this is the Gauss check Gauss Seidal method. Stay tuned for more videos.